Hi everybody, Dr. A here, and in this video we are going to be giving some background information on average normal stress. So what is average normal stress? Well, basically it is computed as the force at a point within a member divided by the cross-section area of that member at the desired point or the point of interest. And we typically use the symbol, the Greek letter symbol sigma, lowercase sigma, to designate average normal stress. So if you look at this sentence here, and I suggest you write this down, but if you look at this sentence here and you look at what it's saying is average normal stress, sigma, is equal to force divided by cross-section area of a member at a particular point or a particular desired location. So let's take a look at the side view of a member, okay? So let's say that we have a slender member here, okay? And let's say that it has a force passing through it, okay? We're going to call this member an axially loaded member. So let's write that down in parentheses, axially loaded member. And we give it that name axially loaded when you have a force that is passing through the longitudinal axis of the member or the long axis of the member, axially loaded member. So if we want the average normal stress within this member, let's say at this particular location here, so what we do is we make a little cut section at the location we're interested in, and we look at a free body diagram of that cut section, and here's the applied load F. Well, in an axially loaded member, if you look at how I drew this, this is a constant force F throughout the entire length of the member, which means that this force at the desired location is going to have magnitude F. And then you look at the cross-section area at that desired location. So what we're looking at now is what is the area inside of this member. So in the figure I drew here, it's this little spot right here. If I expand that and I draw it bigger, then we're looking at this cross-section area. Again, it's the area inside the member if you put a cut plane or a cut section through a particular point. This is that area that we're referring to, area here. So again, it's the internal force, F, divided by the cross-section area at a particular point in a member, all right? Now, the simple formula for that is, of course, just sigma equals F over A. That's the simple formula we see most often. So what are the units? What would the units be of stress? So let's look at this. Units in SI, the base units would be, for example, newtons per meters squared, okay? Which a newton per meter squared is sometimes called a Pascal. So we can say 1 newton per meter squared has a special name of Pascal, P-A-S-C-A-L, which we abbreviate as 1 PA, okay? And then, of course, for SI units, we have all of the SI prefixes that we can use. For example, if you have kilonewtons per meter squared, we could call that a kilopascal. If you have meganewtons per meter squared, you would call that a megapascal, and so on. What about English units? What about if we had English units? Well, we have a lot of different versions of units of stress in English units. One very common is pounds per square inch. Okay, what is a pounds per square inch? Well, we sometimes call that a PSI. So if you think of like tire pressure, for example, that's measured in PSI. Well, pressure is a type of stress. Stress and pressure are often used synonymously as the same vocabulary word, meaning force distributed over an area. Okay, so that's a common type of unit for English units. You could also have kips per square inch. That would be abbreviated as KSI. English units, you could also encounter pounds per square foot. We abbreviate that as a PSF. You could have kips per square foot. We'd abbreviate that as a KSF. And then we also sometimes encounter tons per square foot, which would be abbreviated as TSF. So in summary, in this kind of shorter video, in summary, the average normal stress at a point within a member is computed as the force at a particular desired location divided by the cross-section area of the member at that particular desired location. So that would give us the formula sigma equals F over A, and that carries units of force divided by area. So that's going to conclude this quick overview or background video on average normal stress. Please hit like and subscribe if you found this video helpful.